So let's finish the last part of the last question of the June 2024 CSEC Add Math Paper 2. So this question is on probability and statistics. We did part A, which is on a stimuli diagram in the previous video. So now we're on part B, which has to do with probability, specifically a probability tree diagram. So a bag contains 6 red marbles and 5 black marbles. During 2 rounds of a marble game, a student is required to randomly draw 1 marble without replacement for each round. Construct a probability tree diagram to represent this info, and this is worth 4 marks. So let's start drawing our tree. So first we have to take into account the numbers. We have 6 red and 5 black marbles. We're going to use, of course, R for red and B for black. So there are 2 rounds of the marble game, so therefore our tree diagram are going to have 2 sets of branches, and we're drawing a marble without replacement, so therefore the total number of marbles will reduce each time. So let's start up with the first set of branches. So either we can pick a red marble or a black marble. So the probability of picking a red marble will be 6 out of the 11 marbles in total, and the probability of picking a black marble will be 5 out of 11. So the next round, so if I pick another red marble, given that I already picked a red marble in the first round, remember we're not replacing that first marble, so therefore the total will be out of 10 this time. And since I already picked a red marble, then I have 1 red marble less, so the probability will be 5/10. Now I'm going to leave it as 5/10. I'm not reducing it, right? So the probability of picking a black marble this time, given that I already picked a red marble, the total is out of 10 because I'm 1 marble less. I'm not replacing that red marble, but I still have 5 black marbles. So it's 5/10. And of course, you also need to know that the 2 branches need to add up to 1. Alright? So let's look at the other branch. Probability of picking a red marble, given that I already picked a black marble, so it's 1 less marble in total, and I still have 6 red marbles because I picked a black one first. So the probability of picking a second black marble, given that I already picked a black marble first, and I'm not replacing it, so the total is 10, and therefore since I already picked a black marble the second time around, probability would be 4/10. So this is our probability tree diagram. So let's see what part 2 is. So using your answer in part B, part 1, finding probability that marbles drawn are all the same color. So for the marbles to be all the same color, then we could pick 2 red or 2 black. So let's find the probability of those combinations. Okay, so if the first marble is red and the second marble is also red, so if the 2 marbles are red, then we're looking at these 2 branches here. So it'll be 6 over 11 times 5/10. Sorry, we're multiplying the probabilities across the branches. Okay, and the probability of picking 2 black marbles, oh, my bad, sorry about that. I moved up too quickly in the document. Okay, so the probability of picking 2 black marbles would be these 2 branches here. So that would be 5 11s by 4 tenths. Okay, so let's multiply. So we have 6 over 11 multiplied by 5 tenths, and that will give us 3 over 11. And then the probability of picking 2 black marbles would be 5 11s times 4 tenths, and that will give us 2 over 11. So when we add the two probabilities together, so the probability that all the marbles drawn are all the same color, so 2 red and 2 black, so 3 11s plus 2 11s will be 5 11s. Okay, so that is with 4 marks. Okay, sorry about that. So let's move on to part C now. Given two events A and B, probability of A or B 0.7, probability of A is 0.3, probability of not B, as in B complement, B prime, is equal to 0.6. Calculate probability of A and B. Now notice that they gave us the probability of not B. So therefore to find the probability of B, it will be 1 minus the probability of not B, which is 1 minus 0.6, which is 0.4. So the formula for probability is probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Okay, so if we substitute the values they gave us, 0.7 is equal to probability of A is 0.3, probability of B is 0.4. So we need to find the unknown probability of A and B. So let's simplify. So 0.3 and 0.4 is 0.7. So you see what's happening here actually. So therefore this means the probability of A and B will be 0.7 take away 0.7, which is 0. So part 2, what is the relationship between events A and B? If the probability of A and B is 0, then if we were to draw a Venn diagram representing events A and B, it means A and B do not intersect. That is, they are disjoint sets. And when that happens, we say that the events are mutually exclusive. Since two mutually exclusive events cannot possibly occur together, since the probability of the two events happening, A and B, at the same time is 0. Right, so for 1 mark, we just say events A and B are mutually exclusive.